You're listening to Review Recording 1A, and of course you're watching it too. This goes along with Instructional Recording 1A for Section 1.4, Unit 1, Chapter 1, Mathematics 2200. We'll be using the formula for the sum of a finite geometric series. Example 1. What is the exact sum of the first 10 terms of this series? First of all, we have to determine if it's geometric or not. So let's work on dividing the terms. Negative 5/4 divided by negative 5/8. That's negative 5/4 times 8 over negative 5. We can divide the negative 5's, and we can divide 4 into 8 to get 2. So we've got a common ratio there of 2, assuming it works out the same in the next pair. Negative 5 over 2 divided by negative 5/4. That's negative 5 over 2 times 4 over negative 5. Divide the negative 5 into the negative 5 to get 1. 2 into 4 get 2. So we do have a common ratio of 2 there so far. And for the last known pair, we've got negative 5 divided by negative 5 over 2 gives us negative 5. Put that over 1 times 2 over negative 5. Yes, indeed, it looks like we still have a common ratio of 2. So indeed, it is a geometric series because we have a common ratio. Now we'd like to use our formula to get the sum of the first 10 terms. S sub n equals term 1 outside of r to the n minus 1 over r minus 1. We're doing the sum of the first 10 terms. Term 1 is negative 5/8, and r is 2, and its n value is 10. Minus 1 all over r minus 1, that's 2 minus 1. So the denominator is just 1, so we don't need to worry about that. We've got negative 5/8, therefore. 2 to the 10 is 1,024. We subtract 1, we get 1,023. And so we get negative 5,115 over 8 for the answer. A is correct. Example 2. A ball is dropped from an initial height of 20 meters. On its first bounce, it rebounds to a height of 12 meters. On the second, to a height of 7.2 meters. On the third, to a height of 4.32 meters. And on the fourth, to a height of 2.592 meters, and so on. Find the total of the vertical distances the ball travels by the end of the 10th bounce. So to begin, the ball is dropped 20 meters. It doesn't have an up component to it, it's just down. On bounce number 1, the ball goes up 12 meters, but it goes down 12 meters as well. So it has both an up and a down component. Likewise, on bounce 2, there's both an up component and a down component. So it goes up 7.2 meters and down 7.2 meters. Likewise, on bounce 3, it goes up 4.32 meters and down 4.32 meters. And on bounce 4, it goes up 2.592 meters and down 2.592 meters. So, to summarize, our total vertical distances will be the ups, the distance the ball travels up, plus the downs, plus the original drop. So let's work on the ups. The first rebound height is 12 meters. Then the second one is 7.2. The third is 4.32. The fourth is 2.592, etc. We need to find out if there's a common ratio or a common difference. There's no common difference. Dividing each term by its previous term, we do get 0.6 for the common ratio. So plugging the values in to our series formula, we want to do S sub 10. So it's 12 times 0.6 to the 10 minus 1 over 0.6 minus 1. 0.6 minus 1 is negative decimal 4. I can divide that into the 12 to get negative 30 to simplify my calculation. And then put all that on the calculator. And we get approximately, to 4 decimal places, 29.8186 meters. Now remember, that's only the ups. The downs are equivalent to that, not including the drop distance. The total vertical distance traveled by the ball is 29.8186 plus another one of those, 29.8186, plus the original drop distance, which was 20 meters. So that, and of course those distances are a little bit approximate there, so I'll put a dot on my equal sign. My total distance, therefore, is 79.6372 meters. In summary, the formula S sub n equals T1 outside of r to the n minus 1 over r minus 1 is used to find the sum of a finite number of terms in a geometric series. If not enough information is given in a problem to use that formula right away, you may first need to use relationships from the related sequence to find needed values. For example, you might have to go back to your sequence formula, or as we did in the last example, we had to take terms and divide them to get the common ratio.